All right, welcome back, student pilots. Today, we're diving into a brand new explainer, and this one is an absolute must-watch. We are tackling one of the most notoriously tricky sections of the DGCA CPL air navigation exam, time calculations. I'm talking UTC, LMT, standard time, and the international dateline. I am super pumped to guide you through this because, honestly, once you crack the code on how time works across the globe, a massive piece of that navigation puzzle is just going to snap right into place for you. So picture this. You're sitting in the flight deck of a heavy jet. You're blasting from Los Angeles to Tokyo, ripping across the Pacific, crossing multiple time zones, and eventually hitting the international dateline. Now, how do you manage the math so your fuel calculations are actually accurate and ATC knows exactly when you'll hit your waypoints? Well, if you mess up the time conversion, your ETA is wrong. If your ETA is wrong, your fuel planning is compromised. And in the real world of airline ops, that is literally not an option. So this isn't just some boring textbook exercise, guys. This is everyday pilot math. It's the real deal. Okay, let's dive into this. Here's our highly structured roadmap for today to get you totally exam ready. First, core concepts explained. Second, the numbers and formulas. Third, the international dateline. Fourth, our DGCA exam focus. And finally, a quick recall revision. Let's get to it. Starting off with Section 1, Core Concepts Explained. We're going to build our foundation right from the ground up. First up is Coordinated Universal Time, or UTC. You might know it historically as Greenwich Mean Time, and in the aviation world, it's universally known as Zulu time. Technically speaking, this is the local mean time at the prime meridian, that absolute 0-degree line of longitude. Now, why do we even need this? Well, think about it. ATC clearances, flight plans, METAR weather reports, none of these can afford translation errors when you're crossing international borders. UTC acts as the single, unchangeable bedrock of global aviation. It's our ultimate reference point. In contrast to that, we have local mean time, or LMT. This is the specific solar time that's unique to a single, specific meridian of longitude. Basically, when the sun is at its absolute highest point directly above your head, your LMT is exactly 12 noon. But remember, the Earth is continuously rotating from west to east, right? So that means literally every single line of longitude on the planet has its own distinct LMT. If your buddy is standing just one single degree of longitude to your east, well, the sun crossed their meridian a few minutes ago. They're on a totally different LMT. Now, what's really interesting here is how perfectly Earth's rotation translates into these fundamental mathematical ratios. You absolutely must memorize these for the exam. The Earth rotates a full 360 degrees in 24 hours. Because of that, 15 degrees of longitude equals exactly 1 hour of time. Break it down even further, 1 degree equals 4 minutes, and 1 minute of arc equals 4 seconds of time. You know what? Just pause the explainer if you have to and lock these numbers into your brain right now. They are a total game changer. All right, moving right along to Section 2, the numbers and formulas. Let's hit the whiteboard and tackle the exact calculations you need to pass. Our first vital skill is converting angular arc into time. It's just a 3-step process. Step 1, divide your total degrees by 15 to get your hours. Step 2, take whatever remainder degrees you have and multiply them by 4 to get minutes. And Step 3, multiply any minutes of arc by 4 to get your seconds. Let's walk through a quick example straight from the syllabus. Say we need to convert 77 degrees and 15 minutes of arc into time. Following Step 1, 77 divided by 15 gives us 5 hours, with a remainder of 2 degrees. For Step 2, those 2 remainder degrees times 4 minutes per degree gives us 8 minutes. And finally, Step 3, our 15 minutes of arc multiplied by 4 seconds gives us 60 seconds, which, is just 1 more minute. Add the whole shebang together, 5 hours plus 8 minutes plus 1 minute. Our time equivalent is exactly 5 hours and 9 minutes. See, not too bad. Okay, next up is converting UTC to LMT. The formula here is super straightforward. LMT equals UTC plus or minus the time correction we just learned how to calculate, but the absolute golden rule here is figuring out the sign. Since the Earth rotates counterclockwise when you look down from the North Pole, places to the east see the sunrise earlier. So if your longitude is east, your LMT is ahead in time, which means you add the time correction. If your longitude is west, you're behind in time, so you subtract the time correction. I know it can be a bit much, but for now, just remember, east is ahead, so add. West is behind, so subtract. Now listen up, because this is literally where students lose the most marks on the exam. We're talking about complex conversions, like going from an LMT to a completely different standard local time. Never, ever try to convert directly from one LMT to another local standard time. You will get it wrong. The secret here? You must use UTC as your mandatory anchor point. Step 1. Convert your source LMT to UTC. Step 2. Apply the zone time offset to convert that UTC into your target standard time. Just remember, UTC is the universal bridge you absolutely must cross every single time. And hey, speaking of standard time, you're going to see this specific number a lot, plus 5 hours and 30 minutes. The DGCA exam frequently expects you to just know, completely by heart, that Indian Standard Time, or IST, is locked at UTC plus 530. This actually comes from India's standard meridian, which is 82.5 degrees east. If you do the math, 82.5 times 4 is 330 minutes, which perfectly equals 5.5 hours ahead of Greenwich. So keep that 530 number in your back pocket. Let's shift gears to Section 3, the International Date Line. This invisible line is located on the exact opposite side of the Earth from the prime meridian. So, what happens when you cross the date line? Well, you're either jumping straight into tomorrow or you're falling back into yesterday. If you cross westward, like our earlier example, flying from Los Angeles to Tokyo, you are entering the Eastern Hemisphere. Because they're ahead in time, you instantly enter tomorrow. You advance the calendar by a full day, meaning you effectively lose a day of your life. Crazy, right? But if you cross eastward, flying from Tokyo back to LA, you enter the Western Hemisphere. You enter yesterday, you subtract a full day from the calendar, and you effectively get to live the exact same calendar date twice. And this brilliantly illustrates the whole concept. Mathematically, as you cross that 180-degree meridian heading eastward into the Western Hemisphere, you must subtract a day. You are literally flying backward into time zones that haven't even experienced your current day yet. It's basically time travel. And conversely, flying westward pushes you across that boundary into the Eastern Hemisphere. This pushes you ahead in time, requiring you to instantly add a day to your calendar. Always, always track this shift carefully on your transoceanic flight calculations, or your logbook is going to be a total mess. All right, time to switch from instructor mode to exam coach mode. Section 4, DGCA Exam Focus. Let's expose some of the exact trick questions they're going to throw at you. Here's a classic phrasing trap. Put yourself in the hot seat right now. The question asks, an aircraft is at 90 degrees west longitude. Is LMT greater or less than UTC? Your options are usually A, greater, B, less, or C, equal. Now, a ton of test takers panic and guess wrong here because they confuse their addition and subtraction rules with the words greater or less. They overthink it. So to beat that trap and confidently smash option B, less, you just need this one foolproof rhyming rule. Memorize this right now. Longitude west, Greenwich time best. What does that mean? It means that any west longitude, Greenwich time, which is UTC, is the larger or best number. Therefore, LMT is less than UTC. And here's the flip side. Longitude east, Greenwich time least. At east longitudes, UTC is the smaller or least number. Literally say it out loud during the exam if you have to. Longitude west, Greenwich best. Longitude east, Greenwich least. Okay, let's look at another massive, multi-part DGCA trap. This one really tests your practical cockpit application. The scenario asks you to calculate the legal end-of-evening daylight for a night landing requirement, let's say, in India. The chart gives you sunset at 1800 LMT. The multiple choice options might be A, 1800 IST, B, 1830 LMT, or C, a converted IST time. These distractors totally prey on one specific error, forgetting that the Air Almanac chart only gives sunset times in local geographic LMT, but as a pilot, your watch is legally set to a standard time like IST. So, how do we actually solve this? Let's break down the exact logical flow. To nail this twilight prerequisite flawlessly, you use a 3-step flow. Step 1, extract the geographic LMT for sunset straight from your provided table. Step 2, convert that LMT directly to UTC based on your specific longitude. And Step 3, convert that UTC into your required standard time for your pilot's watch, like IST. The biggest takeaway here? Never skip Step 2. Like we said earlier, UTC is your anchor point. All right, we are in the home stretch. Section 5, quick recall revision. Let's do a 60-second rapid fire to cement all this dense knowledge. Consider this your ultimate screenshot-worthy cheat sheet for your last-minute read before you walk into that exam hall. Ready? 1. 15 degrees of longitude equals exactly 1 hour of time. 2. Always use UTC as your mandatory anchor point for complex time zone conversions. 3. Remember the rhyme. Longitude west means Greenwich best. Longitude east means Greenwich least. 4. Crossing the international dateline westward means you add a calendar day. And 5. Crossing the dateline eastward means you subtract a calendar day. So, what does this all mean for you? Well, mastering these time fundamentals doesn't just pass you on this one section. It directly unlocks advanced general navigation concepts, like astronavigation, where a simple 4-second time calculation error translates to a full nautical mile of drift. You've got to be precise. So are you ready to put this into practice? Head over to CloudDeck at clouddeck.in to drill essential exam-style practice questions on this exact topic. Until next time, keep your calculations sharp and your horizons clear. See ya in the skies.